Okay, then the first thing is to come up with our decision variables or changing cells. So we want how many surveys to send out in each of these three age groups and each of these two states. So that range is our changing cells. So let's color code that. Okay, like that. Okay. So now let's set up the constraints. So the required values are for the number of surveys. Okay, let's do those three first, and then we will look at the percentage and see how to handle that. Okay. So the first one is the minimum number of surveys sent out, that is for the total. Okay, in total we need to send out 2300. So how do we get that? The actual sent out will be the sum of these. So these are the number of surveys that we will be sending out in each age group. All right. So that's the actual sent out. So we need that to be greater than or equal to. Once again, you must enter a label identifying the kind of constraint we have between the left and the right side. Okay. Next is minimum surveys for 30 or younger. So 30 or younger are these two cells. Okay. So we can go like that. You can do a sum, but just two cells, so this is good enough. And that has to be greater than or equal to as well. Okay. And then minimum survey for 31 to 50 years. So 31 to 50 is that group. So it is that plus that. And that again must be greater than or equal to. Okay. Now minimum border state percentage. Okay. Now if you're not careful dividing a number or something by a changing cell, you will end up with infeasibility, or you will end up with non-linearity problem. So it's always better not to divide. Okay. Any division that happens with directly or indirectly going back to the decision variables is a no-no. You can't have the decision variable in the denominator. So one way of handling this is to look at what is the requirement, convert this percentage into a numerical value. Okay, we want minimum border state percentage is 15%. So if it is 15, border state must be 15%. So 15% of what? 15% of everything that is sent out, right? So if you take this total, all the surveys that are sent out, okay, so sum of that, okay, times the minimum border percentage. So that's going to give us a numerical value that we have to meet for the minimum border state. Okay, so we have to have that many. So again, that is greater than or equal to. Now you sum the border states. Okay, so here if you sum the border state, this gives us how many surveys will be sent out to border state residents, right? And this will be 15% of the entire number of surveys sent out. So if this constraint holds, then that 15% will be met. Okay, otherwise you will end up summing this and dividing by the sum of everything and setting it greater than or equal to 15%, will not work because that will introduce non-linearity. So you have to convert it into a linear function, and for that we multiply the 15% to this total and come up with a numerical value that we have to meet at least. Right? The same logic goes for the next one. So we have a 21 okay, of the 51-year-olds. Okay, so if you're now talking about this group of the 51 years or older, okay, we have to limit the border state participation to 20%. So the next one is sum of that. So that's going to be all the 51 and older. Okay. Now 20% of that. Okay. So that gives us the maximum limit, okay, for the 51-year-olds from border state, which will be just that. Okay. Now this is a less than or equal to constraints because this is a limit. So of the 51 years or older, you have a limit of 20%. Okay, let's go back and see where that is stated. So ensure that no more than 20% of those surveyed who are 51 years of age or over. Okay, so that is that group. Okay, no more than 20% live in a state that borders Mexico. So of the total of this, that must be only 20% of that total, which is that. Okay. Now the total cost is, now we do a sum product now. Okay, so this range is the cost per survey in each of those 6 different groups, and this is the number of surveys that will be sent out. Okay, so that sum product will give us the cost that needs to be minimized. So let's color code it differently. So now we are ready to solver. Okay, so now we have the model ready. So next step is to run the solver. So solver, okay, and we want that cell. Okay, so now you have to minimize. So this should be changed to min, and these are the 6 cells that are changing cells, and we add. So here these 4 constraints are contiguous, all greater than or equal to, so they can be entered as one set. Okay, now click add. The other one is a less than or equal to constraint. Okay, click OK. And now make sure that the non-negativity is checked and the solver method is simplex. Okay, and there is no need for option to do anything with options at this point. So click solve. Okay, so now we can request sensitivity if needed, and it turns out that we have nice integer values without even having to ask for integer values, which is good. So sometimes linear programming will give you integer answers. So now we can set up slack or surplus here. So that will be the absolute value of the difference between the right hand side and the left hand side. So for the first 4 constraints, it will be surplus. Okay, and the last one will be slack. So now here, the reason, this is in scientific notation, so this means 1.14 e to the power of minus 13. So that is a very, very small number. So you're talking about 1.14 divided by 10 to the power of 13. So this is a value very close to 0, and the reason why scientific notation is used is because the format is set to general. So if you change that to number and remove the decimal places, then it will be 0. Same here, change it to number. Okay. So we have 4 binding constraints. And this is non-binding, because we require minimum of 345 for that 15%, and then we are surveying 740. Now sensitivity report, and right here, remember, sensitivity report for objective function is about the optimum solution, and for the constraints it is the validity of shadow price. So this says that what will happen to the z value, the objective function value, if you increase the requirement. So for every additional survey that you want to send out, it's going to cost you $5.98. If you want one more from the 30 or younger crowd, then that's going to cost you 92 cents. If it is you want one more, again within this range, one more for the 31 to 50 age cohort, then it's going to cost you 82 cents. And here you have to be careful, because this is number, whereas the requirements are given in percentages. But since we converted the right hand side to numbers, the shadow prices are related to numbers. So if you want one more person in the 51-year or older group to be from the border state, so here this is a less than or equal to constraint. So if you increase the right hand side, then the shadow prices, the cost will go down by 60 cents.